Myself Shanti from the Department of Computer Science. In this video, we are going to see about Pandas in Python. So Pandas is a open source Python library providing high performance data manipulation and analysis tool using its powerful data structures. It is readily available. It delivers robust and adaptable data structures, mainly series, data frame, that simplify working with relational or labeled data. The main purpose of Pandas in Python is to do different data manipulations such as uh, load, prepare, manipulate, model, and analysis. The data loading in terms of Python, data loading is nothing but reading the data from files like CSV, Excel, SQL, JSON. Then data cleaning refers to handling missing values, duplicates, incorrect data. In terms of filtering, extracting specific rows or columns based on certain conditions. So the data can also be modified or create new columns using the Pandas. Similar to database management system, we can summarize or group data with the help of Pandas. Get insight like mean, median, count, all the data analytical and statistical formulas can be used in Pandas. Then combining different data sets, then exporting the data into different formats, that too is possible with Python. Then the types of data structure provided by Pandas can be categorized into three. First one is the series, which is a one-dimensional array-like structure, which will accept only homogeneous data. Then next one is the data frame, which is like a table. It is a two-dimensional array, but it will accept heterogeneous data. The last one is the panel. It is a three-dimensional data structure with heterogeneous data. It is hard to represent the panel in terms of graphical representation. So we will use the containers of data frame to illustrate the panels. The core components of the Pandas are the series and the data frames. So series is essential as it refers to the column of the data. Then data frame is a multi-dimensional table which is made up of collection of series. So it is a two-dimensional data structure in that data is aligned in a tabular fashion, that is rows and columns. So here we are giving an example how a series will look like. How can we combine two series to form a data frame? Let me start with the series. The syntax to define the series is, so you have to import the Pandas file, then you have to use the PDE dot series is the function that is used to define a series. In that, data refers to the data in which you are going to create a column like structure, then index, then the data type if you want to refer, then name and the copy. All these will be the attributes of the series function. So it is a one-dimensional array-like object. It contains an array of data similar to the NumPy data arrays. So it will be associated with an index which may be either a string or integer or other data types. By default, the indexing will start from 0 to n. So here we are having an example in which the from keyword is used to call the packages. In that we are importing the series and the data frames. Then we are creating an object that belongs to the series data structure. So then we are using the print function to print the a series which we have created. The first print statement will print the series 4, 7, minus 5, minus 3, plus 3. That was the input we have given. So the index will start from 0 to the n number of values. Then we are having another function which will refer to as an index. Here the range index starts from 0, that is here, and it will stop to up to 4 in terms of step 1. Then the data type is a default value which is int 64. It depends on the version of Python. Then the last one is the object dot values. Here the values are the input we have given while creating the series, that is 4, 7, minus 5 and minus 3. Let's see another example how to define the series. Here we are defining, in the previous example we have defined the data alone. Here we are defining the index also, which can be either numeric or string or any other data types. In this object too, we are defining a series which hold data 4, 7, minus 5, plus 3 with the index D, B, A, C. So when we print the object 2, the output will be like this. In terms of whatever index we have given will be assigned to the corresponding element. So D will be assigned to 4 and B will be assigned to 5 in the order we have given. Now we print the index means we will get the index whatever we have given here. Then in terms of the values, we will have the values 4, 7, minus 5, minus 3. Then if you want to identify the values, so you can give the index as the reference. So by referring the index, you can directly print the values. For example, here I am referring the index A. The corresponding value of the index A will be minus 5. That will be the output we are getting. Then when you want to identify the object to the object, when we want to assign certain values to the already existing index, we can directly assign that. For example, the D is an index which is assigned to the value 4. Now I am changing the a value from 4 to 10. So object of 2, the index here we are referring with a square bracket. The value is defined using the assignment operator. Then print when we print the object 2, the the value of D will be changed from 4 to 10. Then we can also use the slicing concept here. In terms of slicing, if you want to get a part of the series, so we will start with the index. Here object 2 colon 2 refers to the index, but we already have defined an index A, B, C, A, C. Now when I give object 2 colon 2 up means it will print two elements, that is starting from the 0 and 1. Here we are getting the output D is equal to 10 and B is equal to 7. Then when I want to print the individual values using the keys, so here we are using the square bracket to refer the key. So you can also print the value using the dot operator, that is object 2 dot A refers to the key value, that is index value A. So we are getting the output minus 5. Then in terms of array or dictionary operations, so an array can be converted into a series. A dictionary can also be converted into a series. Here we are constructing a series using the dictionary. The dictionaries will be a pair of keys and index. So Here we are creating a dictionary which is in terms of a parenthesis, it is reflected. Then it is converted to a series using the brackets. So now when I print the object means I am getting this output, that is D is assigned with a value of 4, B is assigned with a value of 7, and A is assigned with a value of -5, and C is assigned with a value of 3. So the numpy array operations can also be applied when we will preserve the index value link here. Here we are checking the object 3 is greater than 0. Okay. So now we are assigning the values to object 4 from a available data series, that is the value which is greater than 0 will be assigned to object 4. Here the values greater than 0 are 4, 7 and 3. It will be assigned to the object 4. That is D is equal to 10, B is equal to 7 and C is equal to 3. A is having a value which is -5, which is less than 0. It will not be copied to the object 4. The same way, you can change the values by directly applying the arithmetic operators to the list. Arithmetic operators to the list. Here, I am powering the values using the power function. So, object 3 followed by powering the values by 2. So, here the D value is 10. When the D value is squared, we are getting 100. When the B is 7, squaring the 7, we are getting 49. And the next will be the powering value of the existing value. Then, if I want to find whether a key is available in the series, so I can directly give that is using the in operator. When B in object 3 will return a boolean value. If B exists means it will return true, or else it will return false. So here we are creating a series from a dictionary which will hold string data types. Previously we have seen key as a string data type. Now we are having indexing using the key values. So I have created a data that represent the states of India. So Delhi 10, then Calcutta 20, Andhra 15, and Gujarat is 18. This is a data I am holding which is in the form of a dictionary. Now I am converting it into a series, but with an index of the state names will be termed as a index for this series. So now I created the object 4 equal to series. Here it represents the data and here it represents the syntax. The first one is a dictionary and the second one is a list. Okay. So now when I print the object 4, so I am getting the output. The important thing we have to look here is that in the data I am having the countries Delhi, Calcutta, Andhra and Gujarat. Here in the states, which is termed as the index for this series, will have the names Delhi, Calcutta, Andhra and Tamil Nadu. So the Tamil Nadu has no corresponding values. So here we are printing it as not a number. So this is a reference for missing values. So we will get when the key is there and there is no corresponding values means we are having an identification that is not a number. So now when I am using the null function with this set of series, I am using three null functions, that is null, not null and referring the not null function using the keywords. So when I refer is null means for the corresponding key values Delhi, Calcutta and Andhra, I am getting the return type boolean which is false. Then Tamil Nadu, there is no value is available, so it is referred as a null value, so I am getting true. When I am using the not function, not null function of object 4 means here we are getting true values for the key A's where we are having the value. Tamil Nadu will have the false value because we are referring here not null functions. Then when I refer object of object 4 dot not null means, so here I am going to check the value which is not null and I am going to print the value which is not null. So instead of returning the boolean values, I am going to directly represent the value. Here I am not getting either true or false. I am getting the corresponding key value, that is 10, 20, 50 for the corresponding states. The same thing we are here repeating, in which we are giving a name population to the object. Okay, so the S data will hold the datas, the states will hold the index, which is a list, and S data is a dictionary. Here I am creating a series. In the series, I am giving the name population to the series. I am provided with the series name also. Then here we are having app function, that is population dot name is equal the object 4 dot name is equal to population, object 4 dot index equal to name. That is state will be referred as the index and the series name will be referred as the population. The index of the series can be changed to different index and the index object itself is immutable. The index object here, the name of the object, the name of the series will be the population and the index will be referred as states. The next one is how can we do indexing, selection and filtering operations. So the first series I have created is a range of 4. Then I am using the index 0, 1, 2, 3 as the index value for the series. Now I am referring S of 2. So here S of 2 will be a value which is now the print S of 2 represents the value which is in the range of 0 to 4. So I am getting the value as 2. Then when I am printing the values of 0 and 2, I am getting the corresponding value 0 and 2. So this will be called as list operations for items which is greater than 1. Instead of defining the values, you can use the range function. A list will be a series will be created say, with a range of values that is starting from 0 to 3. Then in terms of sliced or accessing the label based indexes or using the position based indexes. Earlier we are referring the values to, here 2 will be the key value. So automatically we are getting the output 2. 0, 2 will be the index, automatically we are getting 0 and 2. Then I am referring S of 2. S of 2 refers to the index, that is 0, 1, 2. So the corresponding value is be printed here. Then in terms of slicing, now we are going to use a range of values. So first one is I am referring the same series with a colon 2 that refers to the elements starting from 0, 1. So I am getting the output 0 and 1. Now I am referring the value 0 to 2. So that is 0 is first index, 1 is the second index and 2 is the third index. I am getting 3 values. Then I am using some kind of values, that is applying some relational operators. That is I am checking whether the range of value is greater than 1, I want to print that value. Here I am using the function greater than 1, so I am getting the values 2 and 3 only. When I am using negative indexing, I have to start with -2. So the negative indexing starts from the right side of the series. Here 3 will be termed as -1 and 2 will be termed as -2 and 1 will be termed as -3, that is in terms of negative index, and 0 will be termed as -4. Here -2 -2 is a negative index which will refer the element that is in the second position, and I am referring the element starting from -2 that will end with the last element. So that is how I am getting the output 2 and 3. So that is -2 and -3. Okay, so -2 is this element and -3 is this element. Okay. Then in terms of creating a data frame, the next concept is how to create data frames. So the syntax for creating a data frame is similar to the series index. Here pandas dot data frame, that is first one is data, second one is index, third one is the columns, fourth one is the data type, and fifth one is the copy. The data means the data takes various forms like an numpy array, a series, map, list, or dictionaries. It can be also a constant or any other data frame itself. The index refers to the row labels. By default, it is the range of values. Where the column refers to the column labels. The D type refers to the data type of each column. Then the command is used for copying of data. By default, it is false. A Pandas data frame can be created using various inputs such as a list, a dictionary, series, a numpy array, then another data frames as we discussed earlier. In the next slide, we will look after how to create a data frame from the scratch. So first step is we have to import the pandas. Without pandas, we cannot implement a data frame or a series. Here we are. There are many ways to create a data frame from scratch, but the first option and the best option is simply creating with a dictionary. Here we are having a fruit stand that sells apples and orange. We want to have a column for each fruit and a row for each customer who purchased the particular fruit. To organize this, we are creating a dictionary and converting it into a data frame. So now I am creating a dictionary with apples as the key. In the apples, we are having a list of values, and orange is a key which is holding a list of values. Now I am converting that data into a data frame, that is df. It is equal to df is a variable that will refers to the data frame. Pd dot data frame, that is the function used to create the data frame. The data which is already created data in a form of dictionary. The output will be like this. So we are having the index 0 to 3. So two column structures, that is true. The rows and columns. Here all the values are created according to a table like structure. How did the pandas work? Each key value item in the data corresponds to a column in the resulting data frame. The index of this data frame was given to us on creation as the numbers 0 to 3. But we can create our own index when we initialize the data frames. So if you want to have customer name as the index means, you can refer that. Here I am while creating the data frame itself, I have given it as pd.data frame followed by data, that is index equal to, I am giving set of customer names. So instead of zeros or an index, we will have the customer name who purchased apples and oranges. So if I want to get how many fruits a particular person has purchased means I have to use the LOC method. So that is we could locate a customer order by using their names as the index. So for that I am using the function LOC, df.loc. When I prefer give the customer name, I came to know how many items the customer has brought. Then in terms of pandas, I can create from the dictionary using the from dict function. Pandas dot data frame from dictionary data comma orientation, then data type on the columns. So here data represents to a dictionary of the form field area like or field dictionary. So orientation refers to the columns index. Default it refers to the column. If the key of the passed dictionary should be the column of the resulting data frame, we have to pass the variable columns. Otherwise, if the keys will be from the rows means you have to pass it as index. The default value will be columns. Then data type refers to the data type infos, otherwise it will infer the as none. The columns means list, by default it is none. The column names to use when we are doing the orientation, that we either it may be an index or column. Whenever we use columns means it will raise the value error. So let's see some examples regarding the pandas orientation. So in the first one, I have created two columns. So column 1 and column 2. Now, this is a dictionary. I am converting this dictionary to a data frame. That is pd dot data frame dot from dictionary of data. The output will be like this. Here we are not referring any index. Now, in terms of the same thing, I am creating a row which is holding the values 3 to 1, 0, A, B, C, D. It is having not columns, rows. So here I am using the orientation is equal to index. So here no columns will be there. So instead of creating like this, it will create it as a row. So row 1, 3, 2, 1, 0. In row 2, we are having A, B, C, D. This is the two ways of using orientation. Now, the next one is I am creating a orientation which is indexed, but I am referring the column names instead of 0, 1, 2, 3. I am giving the column names A, B, C, D, that is pd.dataframe.from dictionary data comma orient is equal to the index. Index is it will be created in the form of rows instead of columns. Then columns is equal to A, B, C, D. So that is the index given to that particular rows. So loading of data frames can be done from different files. These are all this from files it is supporting. So CSV, Excel, HTML, then HDF5, then JSON, SQL, all these files can be read and converted into a data frame using the read function and the to function. So we can see CSV and JSON files in detail. So here I am importing a CSV file, that is import pandas as PD. Data frame is equal to PD dot read CSV. In within double quotes I have to refer the data set which is currently available in the current working folder. So next one is I can create the data frame with the index column is equal to 0. So I am getting the values in this Excel. This VBE is converted into a data frame. Then whenever I am reading with the CSV file, all you need is a single line to load your data. So that is PD rot, read CSV, that data set name. CSV does not have indexes like our data frame, so we have to include the index column when reading. That is index underscore column is equal to 0. Here we are setting the index to be from 0. So next one is whenever I am reading a data from a JSON file, which is essentially a stored Python dictionary, Pandas can read this just as a easily using the read JSON function. Notice this time our index came with us correctly since using JSON allowed indexes to work through nesting. Pandas will try to figure out how to create a data frame by analyzing structures of your JSON, and sometimes it doesn't get it right. We need to set the orientation keyword argument depending on the structure. The only thing we have to include the orientation so that the index will be easily assigned. Here I am having a dictionary, that is apple, then orange. Here I am importing it as a JSON file. Then we are getting the output like this while reading the data file. This is the JSON file, and this is how I am importing. This is the structure of my output. Then while I am reading another data similar to the JSON, I have this data which is in the form of rows, and the customer number. Previously we have seen the customer number will be in terms of row, and the fruits names is in terms of the column name. Here when we want to change the layout like this, we have to give the customer name as a header, and the row names will be the fruit name. We have to represent the dictionary in terms of like this. This will be in a JSON file. Then whenever I am reading the data from the JSON file, orientation is important. When I give orientation is equal to column means it will take the data like this. When I want to give the orientation in terms of rows and columns, so we have to give the orientation is equal to index. Orientation will equal to index means it will create the customer name as the row name, and the fruits name as the column name. If you give column, that is the form of dictionary has to be represented as such. So you have to give orientation is equal to column. Then the converting is also possible in terms of the CSV file or JSON file. So we have to use the function to underscore the type of representation. For example, if it is a CSV means you have to give it as CSV file. If you want to convert it into a JSON, then you have to give it as JSON. Okay, so when we have saved JSON and CSV file, all we have to input into those file is not our desirable file name, with the appropriate file extension is a must. Data frame has hundreds of methods and other operations that are crucial to any analysis. So as a beginners, we are here in this video, we are performing simple transformation and fundamental statistical analysis only. So we load this data set from the CSV and designing the movie titles to be our own index. So here I am getting the movies.csv file, and the index column will be the title of the movie. The first thing to do when opening a new dataset is to print a few rows to keep as a visual reference. For that we are using the function head and tail. So the head will refers to the first few rows which are represented inside the bracket. The first movies df dot head will return the first row of the head, CSV file. Then if I represent some numerical values, for example, in the second example, I am referring movies data frame dot head is equal to 10. It will represent the first 10 rows, whereas this will represent first 5 rows of the data frame. So then I want to print the last 5 rows, I have to use the function tail. If I want to restrict the numbers means I can refer the values. For example, here I am referring with 2. That means it will return the bottom 2 rows alone. Then getting info about your data. You are having a CSV file. You don't know the details or the uh, data structure of that file. So you can use the function info. Info provides the essential details about your data set, such as number of rows and columns. Here it is using the number of columns of null values, what type of data is in the each row, and how much memory it is occupying. Here I am having an data structure that represents the movie. Here I am having how data columns, total 11 columns are there. So these are all the columns, that is rank, generic, description, director, actor, etc. etc. So they here we are having 100 data, 1000 data which belong to not null, and the data types. If I use the shape function means it will represent the number of rows and columns. Here we are having 1000 rows and 11 columns. And how to handle duplicates values in terms of data frames. So if I want to, the data set does not have duplicate rows, but it is very important to verify you are aggregating duplicate values. So we will have a simple example using the append function. We will copy the movies.df to another temp.df. So we are appending two movies data set into a single data set. For that I am using the function append. Temp.def is equal to movies.df, which is an existing data frame, then dot append movies underscore data frame. So it will create all the data in two numbers, that is will lead to duplication. When I use this shape function means the columns will be 11 only, but the rows are duplicated. Now it is showing 2000. Earlier it was showing 1000. Now, if I use the drop duplicate function to the temp data frame, so now when I am using the temp data frame shape function means here it will drop the dual rows which are repeating. So we are getting the value 1000 comma 11 as we previously see. So just like append, the drop duplicate methods will also return a copy of your data frame, but this time with duplicates removed. Calling the shape function confirms we are back to the 1000 rows of your original data set. It is little verbose to keep assigning data frames to the same variable like in this example. For this reason, Pandas have the in place keyword on many of its methods. Using the in place keyword or the equal to true, we will modify the data frame object in place. Here you are using the function drop duplicates with an argument in place equal to true. So that we can avoid duplicate values. Another important argument for drop duplicates is keep, which has three possible options. First one is first, that is drop duplicates except for the first occurrences. Then last, drop duplicates except for the last occurrences. False, drop all duplicates. These are all the functions which will be available in the drop duplicate function. Then understanding the variables of a data frame, we are using a function called describe. Using the describe on an entire data frame, we can get a summary of the distribution of the continuous variables. So it can also be used on categorical variables to get the count of rows, unique count of categories, top categories, and the frequency of the top category. So when I use the gener function along with the describe, I am getting the variables count is equal to 1000, unique is equal to 207, that has The generic column has 207 unique values. The top value of this one is action, adventure, science fiction, which shows up 15 times of frequency. So this is how the genre will use to describe the individual values about the data frame. Here we see some examples how to create a data frame. So now I have created a data frame, data which belongs to the list data type. Now I am converting the list into a data frame so that I am getting the values along with the assigned index, that is from 0 to 5. Now I am creating the data frame from a dictionary, that is name will be the key value, A and B will be the input value, age will be the column name along with the values 30 and 45. Here in this example, I am applying a value which is not readily available. In the first value, I am clubbing two types of dictionaries here. Data is equal to A1, B2 is the dictionary, and A equal to 5, B is equal to 10, C is equal to 20 is another dictionary. The two dictionaries are combined and converted into a list. That list is again converted into a data frame. Here A, B, C will be the header column headers, but the C value is not available in the first dictionary, means we are getting the output not a number. Then in the same way, I am assigning the index to this value. The index equal to first and second. Instead of getting 0, 1 and 1, I am getting here first and second. This shows how to create a data frame with a list of dictionaries, row indexing as well as in a column indexing. In the first, in the data is holding a two dictionaries, one dictionary with a value A1, B2, and the second dictionary is having A equal to 5, B is equal to 10, C is equal to 20. So both are dictionaries and they are combined into a list and they are stored in the variable D here. So now with the two column index, value same as dictionary keyword, I am giving the values, that is data followed by index equal to first and second, and the third one is I am giving the column names A and B. So now the third value C is equal to 20 will be omitted. Only 2 A equal to 1, B is equal to 2, then A equal to 5 and B is equal to 10 will alone be created, omitting the third value C is equal to 20. So in the second dictionary, I am creating the first and second one as the row index and the column index will be A and B1. So when the B1 is not available inside the existing dictionary, so it automatically shows not a number, not a number. Here we are having B only. We are not having B1. So automatically it will shows not a number. Then creating a data frame from a dictionary of series. So here I am having a series which has the values 1, 2, 3 and the index will be ABC. This is the first element of a dictionary. It is a series. The second one is 2. 1 refers to a series and 2 refers to another series which has the value 1, 2, 3, 4 and the index will be ABCD. So I am converting these two dictionaries of a series into a data frame, that too possible with the data frame. Here I am having the index A, B, C, D. A, B, C, D I am having. The next one is I am having the column name 1 and 2. I am having the column names here. Then I am having the values 1, 2, 3 as the value of the 1, that is here. Then second one is 1, 2, 3, 4 for the second value, for 2 value. So here 1 will not having the D value, so I am getting the output not a number. Then importing pandas in terms of column addition and column deletion. So adding a new column to the existing data frame object, then with the column name by passing new series. So I have created a Panda series. Then the series is converted into a frame here. So this is the output. Now I am adding a new column by passing a series here. That is already I am having the DF, that is a data frame. I am here passing the 3 as the next value. Here I am passing another series, that is PD 10, 20, 30 with an index of ABC. So adding a column, 1, 2 is the already available data frame. Now I added the third column 3. So adding a column using an existing column in the data frame. Already I am having 1, 2, 3. Now I am adding this 1 and 3 to get the next column, that is 4. So 1 and values 1, 2 values will be added, that is 1 and 3 values will be added. I am getting the fourth value by using the addition of the values of 1 and 3. Here we are getting the output. Here 1, 2, 3, 4 is the column name. A is the value. A, B, C, D is the index. So we have created this one. Again we added a column 3 with the values 10, 20, 30. The fourth column is the combination of values from 1 and 3. That is 1 plus 10 is equal to 11. 2 plus 20 is equal to 22 and same on. Then the next, as similar to the addition, we can remove the data frame columns as well as the data frame. So when I want to remove the first column using the delete function means I can specify the column name. Here I want to delete the first column. So I am using the function del data frame name followed by the column name. Then the same thing can be also done using the operator pop, that is using the function pop df.pop column name. So it will remove the column 2 also. Slicing in data frame. Slicing in data frame can be done similar to the slicing we have done in the series as well as in the list or dictionaries. So I am having this data frame DF with the two elements, that is 1 and 2, which is the range of values 1, 2, 3, 1, 2, 3, 4. So now I want to slice the values from 2 to 4 means I am getting the value 3 and 4 along. So 3 and 4 value is displayed when I slice with the range of values. Then addition of rows also possible. So initially I have created a Pandas from a data dictionary, that is one is the column name with the values 1, 2, 3, 4 and the index is ABC. 2 is another column name which is holding the values 1, 2, 3, 4 with the index ABC. These two are converted into a data frame. Now I want to add another one column, that is PD dot data frame. Here I am adding one more column, that is 5, 6, 7, 8. So the columns are A and B. A and B. So A and B will have the values, that is 0 and 1 followed by the 5, 6, 7, 8. So this is how we can add rows, whereas the 1 and 2 values are not available. So automatically it will lead to not a number. This is the column we are adding A and B. Then deletion of rows, we can delete the rows using the drop function. So drop of 0 refers to the first row, that is with the key index of 0. So this is the first one. I have created the list. Now I had added a column using the append function. Then I have deleted this row with an index of 0, that is drop of 0 means. So this is the drop of 0. It is deleted here. Then re-indexing, we already indexed the elements with the values. Here I am creating a data frame. So these are all the elements, that is row A, row B, column A, column B, column C, column D with a range of values. The corresponding index will be A1 to A5. So next I have created another data frame. So with A, B, C, D as the rows, but I am having the value, I am having the values A1, A2, A3, A1, A3, A4, A7, A8. So if I want to re-index the value means, so I have to refer is df1 dot re-index like df2. So automatically the values here will be re-indexed. So that is, this will be df2 will be there, but df1 index a1, a2, a3, a4, a5 will be changed to a1, a3, a4, a7, a2. df2 is also available. So here a1, previously we are having the value 1, so the values will be there. Then when the B will have 3, C will have 2, and D will have 4. So the values will be available there, but the index will change. But we don't have the corresponding value for A5 and A7 and A8. So it is showing that not a number. So the re-indexing like function returns an object with matching index to myself. Any non-matching index are filled with a value that is not a number. Concatenating objects. So the concatenating of the data frames can be done using the function concatenate followed by the data frame values 1 and 2. So here I am having the data frame, that is name ABC, name AB and their corresponding values and their marks. df2 will have the value bc, then corresponding values. If I concatenate means I don't refer any index. So I am having the repeated index 0, 1, 0, 1. So 0, 1, first two rows belongs to df1 and second two rows belongs to df2. So now we are getting the concatenated data frame. So categorical data is a major important concept in terms of pandas. There are many data that are repetitive, for example, gender, country and codes. So whenever I am using categorical variables, can take only a limited values. So the categorical data type is useful in the cases such as a string variable consists of only a few different values. Converting such a string value to a categorical variable will save some memory. The lexical of the order of the variable is not same as the logical order. For example, 1, 2, 3 will be the logical order. By converting to a categorical and specifying an order on the categories, sorting, minimum, maximum functions can be used easily on the logical values rather than the lexical orders. As a signal to other Python library that this column should be treated as a categorical value, so we are using a function called categorical. Here I am using the pandas. I am creating a data frame like structure, that is pd.categorical ABCD. So when I print this value, I am getting the output as category 3 object. So that will be A, B, C. Here number of duplications means it will only count the values in the list rather than it is repeating the values. So now I am using a categorical value in terms of a data frame. So first one is I am creating a value ACC. Then we are using the numpile, not a number. Categories is equal to BAC. So now I created this cat into a data frame, that is cat will be the label. So S will be the index, A, C, C and the not applicable. That is, we call it as the index. So when I describe the cat, I am getting this value, that is count 33. Uniqueness is 2C, that is A and C are unique. C is repeated here. Then top value is CC. Then frequency is 2, 2. Then count is number of elements is only 3. Upon that we are getting 2. So the first four rows depict the print df dot describe. So the second four rows depict the df of cat describe. So we are having the same values. So they are called as categorical values. So the important concept in terms of using the pandas is reading any SQL files or database files and enabling database functions, database data manipulation functions on the SQL database. For that, we are using the SQL lit. So first of all, whenever you are using in SQL lit, we have to either install it or check for already installed things. We have to import SQL lit. Connection is equal to SQL dit. Connect is the function to enable the connectivity between the database. Then in terms of similar to the relational database management system, we can directly use the queries using the function read SQL query. Different data manipulation functions such as select, insert, update, all this will be applied to this. So here I am using the select star from the purchase. So here I am establish a connection with the database.db. Then in terms of select from the purchase, here I am getting the output like this. These are all the index. These are all the persons who purchased the fruits. Then like CSV file also we can set index. So to this file, that is index, here I am setting the index as June, Robert, Lily, that is David. All these are the customers who brought this product. By default it will be 0, 1, 2, 3. So I am setting the customer name as the index to this database table, similar to the data frames we have created. There are lots of functions and utilities available in Pandas. It is we have discussed some of the important concepts. So we will continue this one through the next level with the content. Thank you.